Good morning, everyone. Thank you for joining us today and welcome to Production Modeling Corporation's web presentation. Today's topic is Reduce Time to Job 1 with Virtual Commissioning, brought to you by Siemens. This will be presented by Ray Poshadlo. He's a digital manufacturing consultant at PMC. On a housekeeping note, we will be muting all phones and microphones throughout the presentation, limit any background noise. So please, if you have any questions, utilize the Q&A chat at the bottom of your screen, and we'll address those at the end of the presentation. And now I'd like to turn things over to Ray to begin the presentation. Ray, take it away.
Thank you, Brian. Hello, everyone. Before we dive into today's topic, we will start with intros about PMC and simulation tool companies before we dive deeper into virtual commissioning. Since Siemens has a comprehensive suite of virtual commissioning tools, we'll cover the great things that they can do. Then we'll wrap things up with a quick review of the benefits of using virtual commissioning. And finally, we'll take your questions. To provide nice informative breaks in between the slides, we have sprinkled in short but sweet informative videos throughout. Today's session will focus on, I missed a slide, I'm sorry. Here is a brief introduction to PMC. Since 1979, PMC has helped over 700 companies by completing more than 7,000 performance enhancing initiatives worldwide. Our commitment to excellence has brought us to the point where we are the largest independent industrial engineering services firm in North America. PMC has worked with hundreds of businesses across all industries to improve their business performance. Shown here are just a few of our current and repeat customers. Today's session will focus on virtual commissioning, but here is a sampling of the other services PMC offers. I'll just give you a moment to look at this. Okay, simulation tools fall into several categories. Since people are often unaware of the differences among the tools or even the existence of any of them, we'll briefly explain the major categories. Note that not all simulation tools offer virtual commissioning capabilities, but it's useful to know what simulation tools are available that may help you to improve your processes. Discrete event tools like plant simulation, simulate, and AutoMod let you analyze the operation of a line, entire departments, or a whole family. It's a perfect tool to identify bottlenecks and play what-if games to eliminate them. You can optimize overall items like throughput, buffer or inventory sizes, scheduling, and workers. A discrete event simulation is often referred to as throughput simulation. Oh, by the way, our animated title screen for this webinar showed plant simulation in action. You may have noticed that, like Process Simulate Robotics video that will be coming up. This is a body shop. The difference there is that Plant Sim was doing what it does best, simulating entire lines, departments, or entire plants. At this level of detail, every single action of a work cell does not have to be modeled. It can be simplified, but the total cycle time must match. The example model here shows trucks delivering parts on pallets, a forklift unloading them, a crane unloading the pallets, robots placing them on conveyors, which lead to two production areas that include workstations, workers carrying parts, and a mezzanine testing area. AGVs at the right deliver the parts that are stored in an automatic storage retrieval system. Finally, delivery trucks loaded with pallets leave. Kinematic tools like Siemens Technomatics Robcat and Process Simulate Robotics let you perform office programming, online programming, analyze the real-time motion of robotic work cells, optimize cycle times, optimize welding sequences, and increase process quality. The next slide shows Process Simulate, Modeling robotic stations in an automotive body shop. Note that Process Simulate Robotics models down to the finest level of detail. That is why it is perfect for modeling individual work cells where this level of detail is required. All righty, now we've come to ergonomic tools like Jack and Process Simulate Human, which let you analyze human motion and optimize the ergonomics of human operation to enhance worker efficiency and minimize injuries. Note that the focus here is on the actual motions that a worker makes in order to complete a task. Pedestrian flow tools like pedestrian dynamics and AnyLogic model the behavior of people moving on sidewalks, stairs, and escalators, etc., in stores, stadiums, airports, etc., in normal and evacuation scenarios. The pedestrians are aware of others, alternative pathways, and obstacles around them. Like in the real world, their behavior is random, including walking at different speeds, going around obstacles in different ways, passing each other, etc. Computer-aided engineering tools like NXCAE has a suite of tools like SimCenter that let you analyze specialized items like thermal and flow analysis and finite element analysis earlier in the design process. There are numerous features here like designing flexible wiring harnesses, additive manufacturing products, and acoustic simulations. You can even hear the simulated sound of a machine running that you've changed, and mechatronics concept designer for machine design. This results in better performing products and machines. Computer-aided manufacturing tools like NXCAM let you analyze specialized items like tool design, NC programming, feature-based machining, and collision detection. This automates the development of molds, dies, and fixtures for higher quality, lower cost, and faster turnaround for machining. Just in case you have never heard the term virtual commissioning before, our next topic will let you know what in the world virtual commissioning is. Setup and ramp up of the control systems implementation for robotics and automation is called commissioning. Traditional, this step is done after the physical system is built on the shop floor before job one. Virtual commissioning tools let you develop, test, and optimize commissioning early during the planning and design phase in a virtual environment, before production starts, before connecting to the real system. It uses highly accurate digital twins of equipment like robots, PLCs, conveyors, light barriers, etc., without any risk to the real facility. There are two major types of virtual commissioning. For software in the loop, a simulation model interacts with a digital twin of hardware like a PLC. This lets the simulation model interact with the exact same programming and behaviors in the real world before equipment is installed in the plant. For hardware in the loop, a simulation model interacts with the actual PLCs, again, before they have been installed. Both types ensure that the control logic used by the model is the same as in the real world. This avoids the problem of a model using different control logic programming. The problem of a model using different control logic programming can vary from the model still accurately matching the throughput of the real world to being so far off that wrong, very expensive decisions could be made. Based on the model, the biggest headache for nerds like me who enjoy building simulation models full of custom programming is that the model might have some garbage in it that could result in much bigger garbage out of it. That's why no matter if you use virtual commissioning or not, you should make sure that the control logic in the simulation machines it matches that of the real world. A few years back, my first virtual commissioning client had this very problem in the past, which was not discovered until the plant was built, and it didn't meet the throughput goals that the model indicated could be met. You guessed it. The problem was that the model did not match the same control logic as the PLCs. So they wanted to make sure that they didn't get burned again. And some problems were discovered before they actually set the system up. Most of them were okay though. Our next topic discusses the powerful suite of virtual commissioning tools available from Siemens. It is easy to get them confused with one another. Siemens tools provide hardware-in-the-loop virtual commissioning through more than one PLC to PLC controller communications protocol. For example, Technomatic's plant simulation can communicate directly to controllers via the OPC Classic or OPC UA protocols. PLC Sim Advanced is a very powerful digital twin of an S7 1500 hardware controller that provides software in the loop virtual commissioning. Note that several instances of PLC Sim Advanced can be made on your computer to provide digital twins of more than one controller. WinCC has great user-friendly tools for the configuration of somatic HMI, human interface operator panels with a real life or a virtual controller. We have another video that shows you what this cool tool can do. Notice they're just dragging and dropping all these built-in items or custom items. Really nice if you've got some application for it. One thing I really like about that video is it highlighted a lot of the benefits of any type of virtual commissioning. Now, Simit is a simulation platform that is capable of comprehensive automation, project testing, and process commissioning all in one platform. It can also be used as a training tool to teach operators and maintainers how to efficiently run their plant. Simulate can communicate with hardware, PLC Sim Advanced, and NX MCD, Process Simulate, and Plant Simulation. Simit has several libraries of components that can be dragged and dropped. For example, the FlowNet library can simulate pipe system, pressure and temperature of gases, liquids, etc. And the drives library provides components for simulating drives. Note, Simit lets you easily switch between software in the loop commissioning using PLC Sim Advanced and hardware in the loop using Simit units. The TIA, Totally Integrated Automation Protocol, reminds me of a shopping mall that carries nearly everything. TIA brings nearly everything except for the kitchen sink in one interface, from digital planning to integrated engineering and transparent operations, including simulation tools. From field level right on up to the cloud, the TIA totally integrated architectural portal seamlessly connects a comprehensive array of hardware, software, and services tools in several categories. It's an open system architecture that allows integration of new technologies. The end-to-end consistency reduces expenditures, saves time, and enables the step into the next dimension on the path to the digital enterprise with room for future innovations. You may have wondered where and when the numerous Siemens simulation and virtual commissioning tools are used. At the top, we have the broadest level, production lines and entire plants or other facilities. This is where Technomatics plant simulation, my personal favorite tool, is used, whether in standalone simulations or for virtual commissioning, especially for material handling systems of conveyors with complex control logic of determining the most efficient number of AGVs, the number of location of battery charging stations, charging station strategies in order to reach throughput goals. Before we go down to the next level, let's look at a short video courtesy of Siemens showing material handling in a warehouse, including an automated storage and retrieval system, conveyors, robots, and AGVs. Virtual commissioning uses PLC Sim Advanced is used to check the actual PLC code here. So you can see PlantSim lets you visualize warehouse storage racks in 3D and easily change the display of conveyors into several different types like belt and roller conveyors. PlantSim's AGVs can follow tracks like those you see here, or you can program AGVs to move from one simple marker to another without even having to lay out any tracks. And finally, you can test the simulation with PLC Sim Advanced. Now that we've used PLC simulation to check material flow in a warehouse using virtual commissioning, let's move down one level, simulating robotic cells with Technomatics Process Simulate. You already saw a bit of Process Simulate robotics. We have a 2-minute video that shows more details.
Process Simulate enables engineers to use a 3D environment to design equipment and refine manufacturing processes. Evaluating multiple iterations and problem solving are performed in the office rather than on the shop floor, so engineers can be confident that their designs will meet functional and performance requirements before implementation. Siemens offers an integrated environment that allows critical collaboration between engineering disciplines. Manufacturing engineers working in Process Simulate can share information with controls engineers who are developing Step 7 control logic and HMI design in Siemens TIA portal, a state-of-the-art software technology unifying all automation software tools in a single development environment. Using Process Simulate for robotics and commissioning, engineers can validate their logic test mechanical sequences and safety interlocks and run other system diagnostics. Flexible automation systems often include the use of robotics. Control of these robots must be fully integrated with automation control in the system, and the logic in both the robot programs and PLC must be validated to ensure proper function. These steps are easily accomplished using Process Simulate. At the appropriate point in the development lifecycle, operators from the shop floor can be brought into a hybrid commissioning environment for system training. Here, we utilize appropriate amounts of hardware in the virtual environment, so operators can become familiar with both the automation and processes. This step helps reduce errors that would normally have to be corrected during ramp-up. With innovative technology offered by Siemens, companies can confidently get the right product to market at the right time.
I hope that gave you a good idea for what a cool tool that is, along with plant simulation. You might have noticed that the engineer there used both a virtual control panel, an HMI control panel, and a real piece of hardware that was interacting with the software simulation of this whole thing. So it's really nice stuff if you have an application for it. Now, NX Mechatronic Concept Design, which models production machines, is another really cool tool. A functional model provides a common language for mechanical, electrical, and automation disciplines to work together in parallel. MCD allows you not only to see what it looks like, but validate that it works before you build it. This is enabled by the reuse library, from which you can quickly add data to the functional model. This data includes joints, motions, sensors, actuators, collision behavior, and other kinematic and dynamic properties for each component. This allows a physics-based interactive simulation to verify machine operation. We have another nice quick video that shows the simulating of a packaging machine. Be sure not to miss the physics navigator at the left and the user-friendly sequence editor at the bottom. So note how the sequence editor goes through each step. It's a great way to debug the control logic. Okay, now for component physics, Siemens lets you virtually assess and optimize the performance of mechatronic systems. It combines ready-to-use multi-physics libraries with the application and industry-oriented solutions that are supported by powerful platform capabilities to let you rapidly create models and accurately perform analysis. Down at the component communications level, we have Siemens' ability to communicate with controllers. And finally, at the lowest level, we have PLC Sim Advanced and WinCC, where PLC Sim Advanced, again, is a digital twin of the controller, and WinCC is a digital twin of the operators panel. Before we end, let's look at the numerous benefits of virtual commissioning. First, we got debug, validate PLC programming visually. Reduce time to job one by 30 to 60%. That's very significant. Reduce cost. Obviously, you're reducing the time and you're reducing the cost. You get to job one quicker. Reduce unpredictable situations. No impact on running production. Model logic matches the real world. Train users before real systems exist. Offline programming, user-friendly HMI layouts, and a sales tool. We are all done with the presentation. Brian, do we have any questions yet?
Yep, thank you, Ray. We did have a few questions come in throughout the presentation, and we'll get started with those. But please, if you have any questions you want to ask Ray directly, please utilize the Q&A feature at the bottom of your screen, and we'll have him address the questions you might have. So, Ray, the first question that we have is, what is the difference between PLC Sim and PLC Sim Advanced?
There are big differences. One of the big ones is that PLC Sim Advanced can simulate more than one PLC, while PLC Sim does just one. So PLC Sim Advanced provides a digital twin of newer controllers also. PLC Sim Advanced also has time scaling that lets you get results quicker, similar to the time scaling advantages of plant simulation. For example, plant simulation, you can often run a plant for weeks, months, or a year in a very short amount of time. So it compresses time due to the time scaling.
Okay, thank you, Ray. The next question we had, can you use more than one instance of PLC Sim Advanced and I think it's SIMIT?
Yeah, right. Yes, you can use more than one instance of PLC Sim Advanced, so that's cool if you need that too.
Okay, thank you, Ray. Next question we had, what version of Plant Sim is required to use virtual commissioning?
You can actually use any version. However, virtual commissioning is included in a separately purchased Plant Sim library called the interface package. Plant Sim can easily import various libraries, some free, some are at cost. And if you have Plant Sim and if you have a brilliant idea, Plant Sim lets you make your own library, and you could sell your own library if you're out there with a software company.
Okay, thank you, Ray. Another question we had, can Plant Sim use OPC Classic as well as an OPC unified architecture?
Yes, that same interface package library that I mentioned, it has two separate OPC clients, one for OPC UA and another for the OPC Classic. So you can use either one.
Okay, thank you. Yeah, I don't see any other questions coming at this time, so thank you for answering those, Ray. I don't see any further questions, so we'll close the Q&A. For a schedule of upcoming topics, go to www.pmcorp.com and be sure to click on the webinars and resources tab to see what other webinars we have up on the calendar. Also, this video was being recorded, so if you want to check it out again, share it amongst your colleagues, visit our YouTube channel, search PMC videos, that's videos with an S, for other topics of interest to you and your team. That will conclude today's webinar. I'd like to thank everyone for your participation and attendance. We hope to see you at another one soon. Thank you and have a great day.